Hello, everybody. It's a shame we're not able to meet today in person, but I can hopefully share with you some information about the customer portals project that was talked about actually at the last GlobalNOC days, and maybe even a little bit before that in the user group context. I certainly apologize. I'm on my home Wi-Fi. If there's any problems, just speak up and I'll jump back and get going on it. So let's see here. So what I hope to be looking at here in this talk is getting everybody up to speed on what I mean when I talk about customer portals, what were the drivers behind this, what decisions were made, and, a little bit of the timeline that gets us up to where we are today. And since the last GlobalNOC days, what have we been working on? Obviously, it's been about a year, and I would hope that we would have something to show for it in that space during this time. So we've got a couple of examples that we can actually go over demonstrating some of these use cases and the examples that came out of them that are in production right now. And then I wanted to talk about where we're heading next with the project. And I also want to focus, hopefully, on where should we be heading. We certainly have our own ideas of where things are interesting and other projects that we might be working on either because they're related to other efforts within the GlobalNOC, but this might not be exactly what you have in mind either. And the only way that we can reconcile these is, of course, if we talk about them. So as we walk through this, as we go down this path today, things that I think would be helpful to think about would be what additional data sources would be interesting to put up on a portal. I'll just throw out some random, not random, quasi-random ideas. BGP prefix information for your customers. Maybe memory utilization, maybe data derived from syslog. Are there other GlobalNOC systems that we could be tying in here in some sort of meaningful way? Other visualization paradigms or approaches. You'll see that in a lot of these, we use the good old reliable line graph, and that's a great tool. It shows exactly what you want for time series data, but there's other ways that we can tell a story. And we'll see a couple of those as we go through here, but I want people to be thinking about that as well. And then just interaction patterns. For example, I know that some of you all have different authorization requirements, right? It might make sense to rearrange this slightly so that it's a layered approach where we, click down from certain high-level views into more detailed views, or others that you can come up with. And we'll have time as we go. We will have time to talk at the end. As we're going through this, please do feel free to jump in with questions, concerns, or ideas at any point. I believe Corey is moderating the chat. I can't see it at all, so Corey, if somebody says something, just jump in and interrupt me, whatever I might be doing, that's fine.
Yeah, I'll let you know.
Okay. And just as an aside, as a computer buff and nerd and gamer and all that, I would just like to throw out how hard it is to write this without making a lot of references to cakes and lies and scientific laboratories when you're making a whole thing about portals, but we'll see if we can keep it tame. All right, so the story so far, none of this will be surprising, I think, to anybody in this room, but every network grows in size, density, complexity as a function of time. And it's often not even a linear growth, right? The networks that, your networks that we're helping you run today are substantially more complicated and substantially more important in today's world, right? The number of services that these networks are providing has increased, and the runtime dependency of these services, or the runtime importance of these services, has increased. It's not uncommon, for example, for classes to be canceled if, say, Box isn't reachable. All of the teaching materials are stored remotely now, and without them, there's no class. With the advent of COVID, we've obviously all moved and seen the move to e-learning. Without the network, that's just not possible. In some cases, we have the network supporting phone communications, right? Real-time communication between a bunch of people. When these services go down, the impact, the rippling effect is much bigger than it was 10 years ago, 20 years ago, however long ago. And perhaps most interestingly, the types of people that are looking to understand the state of the network have changed as well. It used to be that it might just be some core network engineers. It might be some people that were closely related to the network, whatever. But now you might have the librarian that runs a small school's connection. The school is, doing e-learning, or is somehow using some electronic virtual source as a key part of its education, but they don't really have a dedicated IT environment. They just happen to offload that work onto somebody who's trying their best to keep it working. And so this person who doesn't have a formal background in network engineering is trying to figure out, is Box reachable? Is my school's connection up? Is it throwing errors? And using some of the tools that we have today, require a reasonable amount of understanding, not only of how the network is set up, but also just networking concepts to really be able to figure out the answer to that. And so GlobalNOC has and continues to provide a lot of services that collect and visualize data to help show what's going on in the network. Just to name a couple, we've got AlertMon, Snap, the GlobalNOC database, syslog, ticketing data, and there's others as well. And what we're seeing and what we're hearing from you and from your customers is a growing need to take these, let's call them raw services, and cook them down into something easier to understand. I almost wanted to put the term al dente here. None of these services are raw per se. We aren't looking at the OID counter on a switch. But they could use a little bit more simmering time to get down to a level where it's easier to pull these all together and have them, see the higher level picture. There's a saying from the 1500s that I think is applicable here, that not being able to see the forest for the trees. And I think that the more things change, the more they stay the same, I guess. With such a high degree of information, it's sometimes hard to make sense of what's actually going on. So the answer is clear. We need a portal. But what kind? And what does it do exactly? Should it be a blue portal, a purple portal, a red portal, a square, circle, triangle? And this is one of those topics where when we asked 10 different people what should go in a portal, right? What makes a portal valuable to you? We get about 11 different answers. As we talk about the ideas and what we can integrate and how to represent it, everybody's got a little bit of a unique perspective on what is interesting and what goes into a portal. And I think collaboratively, as we talk about these ideas, we end up with something that's a little bit greater as in sum than the individual parts are, right? There's ability to feed off of each other's ideas, and I hadn't thought about that particular aspect. So every network is a little bit different. Your customers are different. They have different levels of expertise and understanding and interpreting what the data means. When we talked about that librarian, for example, their ability to understand the Snap UI is different than the network engineers that actually really live and breathe the network experience here. Your expectations and privacy concerns are different. Different networks connect services and customers in different ways. Sometimes there's redundant connections. Sometimes there's just alternate paths within the network to the destination. And on the privacy concerns, some networks just keep all of their data public. Sometimes this is mandated, either through a grant. Sometimes it's they just want to be transparent. And some networks don't. Some of them are locked down. Some of that, only pieces of it are locked down, right? It's always a little bit different network to network. And that's one of the things that we've supported and want to continue to support as we move forward with this. Your hardware platforms and routing technologies are different. You might use layer 2 VLANs. You might use MPLS. You might run different routing VRFs. You might maintain your own layer 1 network, or maybe you don't. Maybe you purchase it or rent it from another provider. And Grover talked a little bit earlier about modeling data with services and things in the database, and I think you're going to hear that as a repeated pattern. But one of the things that we've noticed too is that you model your services differently. The interface tags are all different. The circuits are labeled differently. So when I said every network is a little bit different, maybe they're more than a little bit different, but the high level concepts are all still the same. We really want to show the availability. We really want to show the performance of various network services. And so what we did after that GlobalNOC days, or some of those earlier conversations, is we put together this portal users group. It's a subgroup focused specifically on identifying needs for a customer portal. And if you're interested in joining, absolutely hit up Corey if you're interested in participating. We're happy to have as many people on board as we can. As I said earlier, I think that there's a lot of value in getting a bunch of unique perspectives from everybody, particularly as early as we can, because that all just snowballs as the project continues to move along. And the big goal of the portal users group here was multi-pronged. One, we did want to bring people in this space together to talk about their ideas. Get unique perspectives, build upon each other's ideas, come together and figure out ultimately what are we going to be able to do with a customer portal. And lastly, we wanted to nail down what exactly we're going to target for these early revisions so that we can actually begin work. Obviously, every idea is not implementable in revision 1, but we wanted to figure out what was revision 1 going to actually look like so we could do that and continue to iterate. So from this group, we worked to identify this base set of portal use cases aimed at the first revision. And for a given customer, what we decided was we'd show relevant usage information from Snap. So this has been the basis of a lot of what we would call portals back in the day, and we're going to carry that idea going forward. If possible, we would like to include alarm information from AlertMon, being able to show whether or not we're seeing any impacting information from not only the Snap system, which would require some interpretation of a graph dip or error showing up or something like that, but also being able to just take advantage of the fact that AlertMon does a lot of that for you already, and will send alerts if a BGP session goes down or a link goes down or something like that. And beyond the technical aspects of including different data types, we really wanted to also focus a little bit on some of the UX or some of the visual polish on these as well, right? So things like branding information, being able to include information that makes somebody, when they sign into this, feel like they are looking at the CEN portal, for example, or they're looking at their connection data on the iLight network. And the goal was to keep these read-only. So that means that this is not going to provision the OESS circuit for you. We're not building a new OESS UI in a portal system, and it probably won't file your taxes for you or do anything like that, or at least not without paying extra for that feature. Also, you're all welcome for that free reminder about taxes. I think they extended it, but still. And we wanted to do this all hopefully without having to reinvent the wheel every single time. As I said before, the high-level concepts are similar network to network, but the details will always vary. So the goal here was, the question here was, can we accurately capture these high-level views in more or less the same manner presentation-wise for a given network, while dealing with the minutiae under the hood in a way that works with the variability across the different networks. And when I talk about read-only, if you've ever gone to, say, status.slack.com or the Facebook developer status page or the Steam status page for any gamers in the room, that's the sort of view that we're talking about when we aim to make this customer portal. So let's get started. So we had this user group put together, we talked a little bit, we figured out some basic ideas. Let's go ahead and actually get started here. So in order to make sense of the data, we need to identify, how do we connect all these pieces together? Where is the list of customers defined? For a given customer, how are their circuits or interfaces associated? How do we get the alarm data? How do we put this all together in a way that is meaningful to the network and customers in question? And so the initial work that we've done to lay this out, and all of these are in production today, was with the iLight network, the CEN network, Indiana Gigapop, and Penren over in Pennsylvania to test the waters here. So before we go any further, just a big thanks to all the folks at those networks that helped us work through this process. I know that there were numerous meetings and iterations going back and forth, getting this right, fixing metadata, going back and updating DB records. But hopefully, I think that the work work was definitely worth it, and I hope you all do too. So the basic framework for these networks. So all of the networks listed here support public data. So we were able to sort of punt on the auth-z issue, at least for the immediate time being. It was an easier way to get started. The use case and the interaction pattern that we talked about is wanting customers to be able to access the page, find themselves, and then see their associated traffic. It sounds really simple when you just put it that way, but when you go back to how this might have worked earlier, it was go to the Snap UI, hope you enter the right search term, and then hopefully you're looking at the right interfaces and interpreting them correctly. So this is actually a pretty big leap forward as far as user experience, not only with you all, but also with your downstream customers. And as a reminder, all of these networks are modeled a little bit differently. So we're going to have some level of customization, right? Some people, some networks use services, some use interface tagging. Some want to model different types of services in separate categories. So we need the ability to tune all of these visualizations accordingly without a backbreaking amount of work. And so what we're going to do is we'll query GlobalNOC DB, we'll query TSDS, we'll find the correct set of information that we need, we'll present it to the user in whatever way that we've agreed to present it, and profit. It's that easy, right? So the building blocks that we've been using to build these so far have been the GlobalNOC database, where service level information like Grover showed off, topology level information, circuits and their hierarchy and all of that jazz, and anything else that describes the higher level concepts that bind everything together, right? That's what the GlobalNOC database is designed for, and it works really well in that regard. I think we've had a lot of success employing that for this project. We've also tied in AlertMon. As I was talking about before, we've got real-time status of monitoring checks. And not only that, AlertMon will tell you what pieces of the infrastructure are impacted, right? We might have a link down and it'll tell me it impacted this particular interface. And I can use that to then actually make some interesting analysis, and we'll take a look at that when we get further along here. Snap TSDS, of course, for our time series data. Most commonly, this is bit error or packet rates, maybe some CPU usage, and there's a host of other telemetry, and I'll show a few examples of some of the other things when we get towards the end here. And then for the actual visualization platform, we've been using a tool called Grafana to tie back into all of these different systems. And most of the development work, when we think about it, has actually been in the space of Grafana. There's been some work defining things in the database or cleaning them up as needed to make it work, but the actual development work has been in the Grafana space. In order for us to be able to mock up elements, we've had to build out integration between Grafana and these other elements listed above, Snap, AlertMon, and the database. And what this really has afforded us as this project has gone on is not only a good degree of flexibility, but most importantly, what I call the time to try barrier, and how we've dramatically reduced that. Prior to using a sort of pluggable framework like this, the development of any of these views would require custom code to be written, and that can really bottleneck the process, particularly if we aren't really sure what we're going to be doing, if we're just experimenting. If you just think about it, it's fairly obvious. The time, if we're going to create, say, a pie graph, to go out and get a JavaScript library and figure out how to hook it up and connect it to your data, not only requires somebody with a programmer background, but it also requires somebody with access to the server. It requires time connecting them all together. Doing that same thing in something like Grafana takes on the order of minutes, and it can conceivably be done by anybody. It doesn't have to be, say, me or somebody on my team, although it usually is. And that's what I mean when I say time to try. We can throw that pie graph out, we can look at it, and we can say, oh yeah, that looks great, and we're done. Or actually, now that I see it, it doesn't really capture what I was hoping for, and we can just toss it, and we're out 5 minutes worth of work, not 3 days worth of work. So the ability to iterate, the ability to tune, and the ability to make progress or experiment has been dramatically reduced by this approach. So what I wanted to look at now is I have got a couple of screenshots, and then I will page out to actually do a little bit of a live demo. We'll look through the iLight one, for example. But what I wanted to do right now is look at the 4 examples of how this turned out with CEN, Indiana Gigapop, Penren, and iLight. And I think one of the things that I hope that you will notice is that they're all pretty similar, though they're not exactly the same. And I think that that is very representative of the fact that, or to me, very indicative of successfully implementing the idea of capturing those high-level concepts of what are we trying to show off here, while obfuscating all the gory details behind the scenes of how a given network is implementing its particular bits. And after we go through all of this, I hope that, or maybe at least I should say, I might not be surprised if there's a couple of other tweaks that people have once they see some other people's views as well. So if we jump over, we'll start with CEN. And CEN has the esteem of being the first ever member portal in this new system, and we're a pleasure to work with when we were laying it all out. The key things I've indicated here on the UI. So what we have at the top left is the ability for a member is basically just a drop down listing all of their members. This is all derived from the DB. So as new members are added or old ones maybe go away, there's not any work to be done to maintain this. It's all very automatic. It's all tied into all of these systems that we already have to track this higher level data. On the right side, we've got the ability to do custom branding, right? Somebody's showing up here. This makes it feel like CEN owns this project, which they do, right? And it doesn't have, it has the ability to just, when you come in and look at this, just like when you go to any other page, it feels right to have that branding sit there to showcase, where you are, right? You're at CEN right now. And then what we did for laying out the data is we wanted to lay out not only an aggregate graph showing the totality of all the traffic that a particular member is using, but also what their error rates were. One of the things that was going on here was whether or not if a customer came in here and they were experiencing a problem, they would be able to see without any further contacting engineering or digging into, say, Snap, whether or not we were aware that they were seeing any error rates. As you can see, this particular member appears to be running perfectly clean, so it looks great. And then down below, pretty similar to how other things work, just a bunch of individual graphs so you can see every individual connection. As we move on to Indiana Gigapop, you'll notice that it looks pretty similar. But there's a bunch of key differences here that I want to highlight here. So once again, at the top, they have the ability to select what member you are. And in particular, I can maybe show this as a live example. Their members are broken down into different categories. So there's members, there's vendors, there's other types. So Indiana University is a member. And Indiana Gigapop, when visualizing this for their members, wants to break out the traffic by type. So what is the traffic that we're seeing based on RNE? And what is the traffic that we're seeing based on commodity? So rather than lumping these all together, which we certainly could have, we decided to make them separate. In the database, where this information is all stored is in services. So I won't show this because it's a little bit behind the curtain. But the idea here is that there is a service defined for Indiana University of type RNE traffic, and there are 2 interfaces associated to that. And we use that information to populate this view. Again, like with the member lists automatically updating, the real benefit here is that as information in the database is updated, say a member switches ports or say a new one comes on, they add a port, all of this just updates automatically and there's no further work required. Of course, the corollary to that is this view is as useful as the database is accurate. So, it definitely does require some attention to keeping that all accurate. When we look at this is the Penryn view for their member portal here, and you're probably noticing a theme by now, right? And as I said before, I think this actually represents success. We have this high-level view of showing specific member-facing traffic utilization information to all of their customers, and all of these have been documented in a different way, and they've all been laid out a little bit differently. Um, the way that Penryn opted to lay out its members, for example, is with different services for different types, and they have a lot more types than just routed R&E and routed commodity, for example. So if a member were to come in here, they can pull up their specific service identifier that they are used to interacting with and see all of the relevant stats for those particular interfaces, which is a little bit different than how the other ones work, but again, captures that same high-level goal. And then this is where I want to drop out and go into a live demo, but I captured a slide just in case that wasn't going to be possible here for the iLight one. So I wanted to play around a little bit with that. So let's see if this is going to play ball. Okay. Can folks see that? Corey, can you see that?
Yeah, I can see it.
Okay, terrific. So what we have here is, this is the real production iLight member portal that folks will go to and load it up when they want to see their traffic stats. And just like with the other ones, you'll probably notice a pattern. You've got the ability to select what member you want to look at, and then you've got a bunch of information about it. I think iLight represents the network where we made the most progress integrating beyond just Snap, and is why I wanted to break out and take a look at some of those additional features here. Just like all of the other views, you have, for example, individual interfaces showing their basic connectivity, and we won't go over those too much because we've seen it again and again and again. But what they have beyond that is, you'll notice that there are, and I hope you can see my mouse as I'm doing this, in this top left section, there are alarm indicators.
We can see your mouse, just so you know.
Okay, terrific. And what these alarm indicators do at this level right here are designed to provide a high-level view of what alarms are impacting, in this case, Anderson University right now, and within the time frame selected, which is last 2 days by default, how many alarms were there? So as you can see, both of these are 0 right now, not particularly interesting. I talked with some of the engineers ahead of time, and I couldn't get them to shut off their ports to make my demo more convincing, but trust me, it does work. So if we, and we'll show a little bit of the historical alarms to prove that. So in addition to that, there's also a high degree of customer branding here. So this shows Anderson University's logo, and if I were to change it to say Bethel University, not only does all of the usage change, but so does the logo. So that's kind of nice as well. It's just another element, it's just another level of polish that we're able to bring to bear on these projects. So let's go back to Anderson, and let's go look at the last 30 days. Are there any alarms there? Nope. How about the last 90 days? Well, there's no alarms, but I can tell you one thing. I think this is when COVID started right here. You can see that traffic drop. And I think this might have been a Call of Duty patch release. But okay, still no alarms. Let's go back even further. How about in the last year? Surely in the last year, something would have happened. All right, great. Sometime in the last year, we have seen alarms impacting Anderson University. But what are they? Well, we can scroll further down, and it'll actually tell us. And this is all information that we're gleaning out of AlertMon now. So you can see that obviously in the last year, there were more than 16 alarms total. But what we've been able to do, based on working with the iLight engineers and understanding how Anderson is connected to iLight and how the data is modeled in the database, we're able to narrow that down to only alarms that impacted Anderson University specifically. So you can see, for example, that there was a small outage. There was some backbone work that also impacted them, not directly, but indirectly. and we keep track of that information over time. So this is a very easy way to drop into the view and get a sense not only of what are my active traffic stats, but what does the monitoring system think of my status as well.
Hey, if I can jump in real quick, Dan.
Yeah.
Karen had a question. What if only Anderson University, what if the network only went at Anderson University to see Anderson University's portal? Is it possible to integrate with credentials? If not, is that something that's on the roadmap?
It absolutely is on the roadmap, and I'm getting to it in a future slide, so stay tuned.
We just got a little bit ahead of it already.
Yep. As I mentioned at the beginning, one of the aspects that we used to determine where to begin with this is the fact that these networks had their data completely public to begin with. So there was no risk share, I guess is the word I'll use there with exposing all of this data. But as we move forward, I know that there are some networks for which that is not the case, and we're going to need to figure out a plan to move forward there. In addition to the alarm integration and the branding integration, iLight has one other unique aspect here, which is actually this section right here, related to commodity usage and R&E usage. These graphs up here come from your traditional snap collector, pulling the device, goes into snap, and away you go, right? So there's nothing particularly exceptional about these 6 graphs up here. These graphs, however, come from an entirely different system. They're still stored in TSDS, and they still look like interface data, but they're collected in an entirely different mechanism, and they're stored a little bit differently. What I really want to draw attention to is not the ins and outs, and I'm not going to explain how that works, just the fact that it's possible to begin to tie in more and more of these data sets in ways that correlate additional information. The fact that I had to explain that this was not the same as their regular interface data is hopefully evidence of that. We're able to bring it together in a way that the customer doesn't really care about the ins and outs of how we're collecting their data. They just really care, what's my commodity usage, right? Just cut to the chase here. And I think we're able to do that in this particular case. All right, let's get back to the slides here real quick. Is that working again, Corey?
Yep.
All right, terrific. Okay, so where do we go from here? Just to recap real quick, so we had this meeting, we kicked off this project in 2019, we built out the technology to integrate this portaling system with several of the back-end components that GlobalNOC supports, and we've put several member portals out into production today. This is what people use. They notice when it goes down, right? And so that's great. But we don't want to sit on our laurels here, right? What are we going to go, where are we going to go from here? So this is where I'm really interested in hearing more from people about. And I'll have further ideas in a couple of slides. But I think there's a couple of categories here. There's the A category. This all looks great. I want to get in on this for my network. And we're about ready to start that with OneNet and I2 on this front. But we always like to keep the hopper full. If you think this looks good and it's interesting, and this does require some level of focus from you, then we can absolutely start doing the initial work there. The level of focus really gets back to the heart of the matter of what's a portal and how every network is different. So we have a reasonable degree of customization options available to us. But it does require that concrete knowledge, that tribal wisdom that brings it all together in a way that works best, not only for you, but for your customers. And for some networks, this knowledge may exist within the networking team that GlobalNOC provides, so that that need might be very, very low, might be even zero. But for others, it might need to come from some other sources. There's also the B category. I have more ideas for what I think should be in a portal. Awesome. You should absolutely talk to Corey about joining the users group and generate some discussion about what that idea is and how we could go about implementing it. And then there's the C group, other. There's probably angles that I'm not considering right now. Let me know. I have my own view of where I think we're going with this, but it's my own view, and it's certainly not a complete view. So if you have further ideas about things that we want to consider or figure out how we want to approach, let's start a conversation about that. But in the meanwhile, what I wanted to do next is look at a few things that we're currently exploring. These are a result of some talk with people in the community about some use cases, some of these maybe B and C categories above. And some of these probably branch out from the original definition of a portal that we've discussed so far, but I think that's part of the goal of figuring out where it makes sense to go next. Some of these are maybe less focused on the idea of a customer portal and more perhaps focused on a network engineer portal. But get the brain juices flowing, so to speak. So one of the things that we've been spending some time on in pursuit of some of these questions is mapping. We don't typically think of mapping in the sense of a portal, but I'm going to make the argument that I think that it is. So what we've been doing, we've got a variety of different mapping platforms out there today. So I've got a couple of screenshots here on the right. The top one is the Global Research Map. The middle one is the worldview that we all know and love. And the bottom one is an example of one of the maps that we've done in Grafana. And these all present unique abilities and some minor tweaks to suit the use case at hand. What we really want to do is bring these all together and work to build a unified code base that also includes more support for things like mapping arbitrary data, putting alarms or maintenances on a map. You can imagine a case where real-time traffic data coupled with real-time alarm data, I would argue that that is a portal. It might not be a customer portal, it might be a customer portal, but I think it's definitely a portal. And we're also working on significantly more powerful map edit integrated with the DB, but I won't go too much into that. Something like a replay functionality, right? So I have this great real-time traffic map of my network, but what did it look like last week when some big event happened? And we can actually do this one today. Ben Miller of Kinver was gracious enough to allow me to use this map of the Penryn network. When COVID-19 came around, schools began extending spring break, canceling classes, moving to e-learning, and I think every network in this space has seen a marked shift in the traffic patterns and peaks. So there's a really easy way to get a sense of this, to answer that kind of unique question. What I want to do is look at what did the network look like last year. We already have the topology of the network. We just simply want to go back in time and take a look at what that was. And when we use this with something in the portaling infrastructure, like within Grafana, it's actually quite easy to do that. We can simply adjust the time range and revisualize the map based on whatever time we want. So you can see on the left, we have April from 2019, and on the right, we have April from 2020. And if you're unfamiliar with the legend, the cooler colors mean lower traffic. So you can see that there's been a decrease in traffic during this time as extended spring breaks, school class cancellations, things like that. It's curious what a difference a worldwide pandemic creates. There's also alternate data sources that we can use to make additional portal-like views here. So the use case in this particular instance is I run a layer 1 network. I'd like to be able to visualize something besides bits and packets at the layer 2 or 3 level like we always have been doing. And it turns out we can actually do this as well. And it's just a new idea of taking the tools and taking the data that we have and putting them together in a new way to answer a new question. And so what we have here is a real-time RxTX power layer 1 map. Oron was kind enough to let us use this example. I worked with Bobby Clark to pull out all of their layer 1 circuit information topology defined in the GlobalNOC database, which was very handy, and then just simply connected it with the TL1 optical statistics that we collect in TSDS for them. And that was it. So now we can see, and then we tuned the values on the map legend to make sure that, based on, what Oron deems acceptable levels of power at RX and TX levels for their various spans, we can get a high level view of what is the optical health of the network. And as you can see from here, it looks like things are working pretty well.
Hey, Dan, when you get a moment, Dave Marble has a few questions for you.
Yeah, shoot.
If you don't mind him jumping in real quick.
Yeah, go for it.
Yeah, I mean, I didn't need to interrupt you. I
Oh,
could have
no,
waited.
do,
I
please
could wait.
do.
I could wait to the end. As you know, our implementation is a bit different in that we had started our own portal development, in the meantime, right, or ahead of time, if you will, and so our requirements are a little bit different. But I think you know better than anybody that we are actually using a hybrid of what you're developing, to great success. And so I'm interested in a couple of subjects that have been touched on. One, I don't think you got to your authentication question, but we are highly interested in the authentication question. The other part is this whole idea about architecture. I mean, one of the things that obviously, if we're doing our own portal, then what you develop becomes a plugin to what we do. And so the more you use Grafana and make your implementations extensible, that works well for us, right? Because then we can take that, as a component and plug it in.
Mm-hmm.
So the other, really big piece to us is ServiceNow, and being able to, even in a read-only, just like everything else, see open tickets, plug it in. I think there's some question in my mind between when you implement it in Grafana versus if you're giving us the keys to your Grafana instance, because we have to put it into our Grafana instance. And I'm a little bit unclear, because I'm not a software developer, about the difference between those two things. And I do overall want some understanding at GlobalNOC that there is a opportunity to discuss whether or not it's GlobalNOC building, call it the ultimate portal, or a REN like ourselves is building our member portal. And being, I know there are trade-offs architecturally and otherwise in just your own prioritization on what you work on and things like that, that I certainly want some measure of visibility to, and I know Vincey's on the committee, so those are a couple of things. I think number one, recognize that at a priority level, and no disrespects to maps, right, but at a priority level, that there are a number of discussions that I think GlobalNOC could be a great candidate to help develop in the area of authentication, into the systems. For example, in our case, we got a lot of K-12s that use our managed Fortinet firewall instance, and they need authentication into the portal and then sign on, or single sign on into their Fortinet instance. And we need to build those kinds of authentication systems. And we want to put something like multi-factor on top of that, like Duo. So if you could talk a little bit about those couple of subjects, I'd appreciate it. And by the way, kudos to everything you guys are doing. We've already implemented, as you may know, the traceroute function right into our portal based on what you guys have done, and it's fabulous. So.
Okay. Yeah. Well, first of all, thank you. There's quite a bit to unpack there. I wanted to touch real quick on when I'm talking about the mapping, these are not necessarily in any order of prioritization, or I would say they are perhaps driven by parallel prioritization efforts, for example. So the mapping work that I'm showing off right now, for example, these are all things that exist today. So there's no development work really going into this beyond just the setting it up. The converged mapping platform is something that we've internally wanted to do for our own reasons for a while now, and so we're being able to tackle that. As it relates to the auth issue, I think that right now there's a number of conversations circulating in that field about how we're going to support, I'm not sure what the right term is here. Let's call it third-party auth. I don't know, Luke, if we have a term for that or not.
Yeah, there's probably two different pieces there, Dan. One, we do offer AAA as a service where we can be an auth source as a service for your network. And then the other thing I think you're also talking about, Dan, is integrating with other auth platforms, be it Shibboleth or other existing auth platforms that networks are already using today. And architecturally, we want to be able to support both of those in portals and in other GlobalNOC tools.
Yeah, we are a user of your AAA as a service. We want to build on top of that, with Duo or something like that. But there are a number of discussions going on out here, specifically even in research, to create some kind of similar, kind of technologies. And maybe they're not connecting to bandwidth charts, or maybe they're actually connecting to end session or sensing devices, or they might be in research connecting to a cryo-EM machine or something like that, and a consistent and I would maintain at the GlobalNOC view of something like this with Internet 2 might be a really interesting thing to discuss.
Yeah, and our AAA platform is, there's multiple technologies there, sort of depending on what you want to integrate with. It may be, a web single sign-on, it may be a Radius, it may be an LDAP, et cetera. And I think Dan can maybe touch on it. I don't know if he's got slides on this or not, how it could integrate with something like these portals.
Yeah, I don't think I had a specific example of this question prepared in these slides, but I can talk about it. We've already had requests from a couple of other folks that run, for example, their own Shibboleth instance, right? So there's an IDP that folks are used to logging into that has, for example, the IDP here at IU. We have a number of users that already have at iu.edu credentials. And setting up a secondary set of credentials for everybody is not really in anybody's best interest. It's a lot of overhead for us. It's another thing to remember for them, and nobody really wants to go down that route. We've seen similar in some other cases as well. I believe NOAA is in the same boat here as well, where they maintain a lot of their own access control policy. And so we have experimented successfully in deploying this sort of environment with that sort of auth mechanism behind it. For example, the views that we support for the Indiana campus network are accessible through the Indiana campus IDP, right? They can log in with at iu.edu. We don't have to manage their credentials, and it just works that way. So that would be one example of integrating with a third-party auth, as it were. And then there's, as Luke was talking about, there's also AAA as a service, where the details of that are probably going to fluctuate because it's going to depend on how it all gets managed. But under the hood, how it would work here is basically the same as it works today, where you would log in, it would vet you, LDAP-wise against our systems, and then let you in with or not with the correct level of authorization. And
then Dan, what about the use case that Karen was talking about, and I think Dave was touching on, where, say Anderson University has some credentials either that they're managing themselves or we're managing through our AAA as a service, and they want to lock down, say, some of the portal data to only be able to see Anderson University when one of their users comes in.
Mm-hmm. So we started looking into a little bit of that as well. There is the ability within this framework to limit views to particular groups. So what we started looking at is the ability to map given logins to given groups, right? So the idea would be that you would have a view that was, say, Anderson University, and a different view that was Butler University, and when you log in, it just simply drops you into the right view where there is no ability to change what you're looking at. It's just simply your view.
Yeah, this is David Blake. So like on the AAA side, like we basically already have that capability, at least within the AAA as a service. Like, you know, we can define group membership and, you know, what access individuals get through those group memberships and all of that. I mean, the Ocean people are pretty familiar with this because you've been managing these accounts like for a good while as part of the AAA as a service. So the sort of the bit that Dan's talking about there is how to map those role memberships to portal access and portal settings on the Grafana side. And there's good progress there.
Does that help answer some of that question? I realize it's a bigger question than I'm answering right now.
I absolutely, you know, at the highest level, I'm not anything but repetitive when it comes to this subject. And you guys, Corey, I know, and Luke are pretty familiar with my diatribe on this. Is that there is a need, certainly, maybe this is selfish on the Ocean side, that when we are thinking of building this from a portal perspective, that there's the GlobalNOC portal instance that they can do and build and en masse do it for the member. And in the case of, you know, CEN, that's a classic example. And then there's, you know, us. And I would consider to be, you know, what we're doing to maybe not be unique to Ocean, but other members over time having their own stuff that they want to do. And in fact, Grafana turned out to not be able to be the top end UI because of some of the things it could not do. And so we had done a lot with Kentic and exposing Kentic. So from an architectural perspective, what we end up doing is melding Grafana with our sort of top level UI structure. And I would imagine that there are others around that might be in this same boat. So, especially over time. So I just implore GlobalNOC to continue to remember that maybe their instance is not the be all and is not the portal that everybody connects to do everything that they need to do, but they need to present what you guys do to us so that we can embed it in our instance.
Yeah, and I think that, you know, the AAA service does enable that. You know, the more pieces of your portal that that we don't have any visibility or control in, you know, the more of that work you have to do on your side. But I think the technologies and the tools that we're bringing in our AAA tools allow you to do that. You just have to stitch some of those authorization policies together yourself based on, you know, whatever your backend data sources are that you're integrating into the portal that don't come from GlobalNOC.
Yep, it's all good.
Okay. I think I'm getting fairly tight on time here. Corey, it looks like I've got maybe 7 minutes.
Yeah, that's about right.
Okay. I still have a few slides, but we might move a little bit quickly through them because I do want, you know, there to be more opportunity for discussion at the end here as well. So just moving along at a slightly brisker pace here. Alternate data sources. This doesn't have to be on a map, for example, just including optical information in general is something that I don't think a lot of people have thought about when it comes to customer portals. And then this is what we're also kind of looking at a little bit, which is being able to pull in alarm and maintenance information onto, say, a map, for example, or into, say, a table, right? This is just an example of a handful of alarms that we've seen on the ILA network over some time period that I picked to generate this screenshot. So just, again, ideas to get people thinking about other ways we can start to pull in these different data sets. We can start to look beyond time series data. Everything that we've been focused on so far, alerts are kind of time series data, kind of not. But for example, we collect and store syslog data for a number of networks, and this can be used to generate a number of interesting views and analysis as well. So here, for example, we've got, in the wake of COVID-19, one of the hot items was how was the VPN here at IU being used? As one might expect, the traffic numbers and, you know, external connections and whatnot increased dramatically. Not only just simply in volume of traffic and volume of connections, but just the geographic scope of where people were connecting from changed as people began to go home from living on campus instead. So all of this got put together based on syslog data. How does this relate to portals? It's less operationally useful, but it is a very high level picture, right? It is a very good example of how a picture is maybe worth 1,000 words, and how you can, generate some interesting visuals when trying to explain or understand a particular data set. Alert-based data. So we have a whole wealth of alerting knowledge, current and historical, and most of the time, these alarms are capable of, they do something a little bit more involved than plotting a number over a line about telling us whether something is working or not. The screenshot that I have here is an example of a dashboard that we recently deployed into production for use by our internal staff. And the use case for us was general awareness. Mail seems slow for me. My messages don't seem to be getting through. Maybe I should go ask in the chat, hey, is anybody else experiencing mail problems? Because what we were seeing is that when there are actual problems going on, ironically, one of the worsening factors is the deluge of people asking if there's a problem. And so what we're hoping is that with something like this, if you are, say, for example, suffering a subpar mail experience, you can go check in to see if we're already seeing alarms on it, right? If we are, there's good news. You don't really have to ask us. We already know something's wrong. We already have a ticket on it because it's from the alerting system, and there's no real need to follow up with us. It'll be, cleared when somebody fixes it. And so while this is focused on internal system health monitoring, there's certainly no reason why this couldn't be turned around and pointed at a network use case. Any check that we have implemented in AlertMon today, or could be implemented, which is $anything, we can pull in here. So, for example, if you want to show the connection or the status of your BGP connections to Amazon, we can do that here. And where this maybe starts to become interesting is that if you were to look at AlertMon and see that there is a BGP session to Amazon down, is Amazon down for you? Well, it depends. Do you have 2 connections, 3 connections? You might have peering points with them in multiple locations. This is where something like this is able to distill that information down. If we know there's supposed to be 3 of them and only 1 of them is down, well, we can just show that it's impaired, right? It's not down, but it's not really up either. And so we're able to distill a lot of that knowledge into something simpler to understand, not only for you, but your customers in a lot of cases. Are any of your backbone interfaces showing errors, high traffic? Well, we can condense that down into one number, right? It's either yes or no. And these already exist as monitoring checks for many networks. We just need to work on defining how to pull them in and what to show. We've got ticketing data. I'm going to gloss over this a little bit here. I just took a screenshot of some of the tickets for my particular team, but this includes maintenance data, incident data. Imagine the case where we've got a customer logs into their portal view and they can see all of the incidents currently impacting them, or the current upcoming maintenances that might be affecting them, right? So there's a nice condensed view alongside all of the rest of their data that includes a little bit higher level human knowledge, right? So like a ticket is human curated most of the time, and that's going to be able to give you a little bit more control over that. In that same vein, things like RSS feed data. There's the ability to integrate a variety of common feed mechanisms. I picked RSS in this case, which is a relatively new addition here in Grafana, where we can take an external, and when I say that I mean external from GlobalNOC or from us, whatever, and pull that human curated information into a view that we can then, somebody can click in and go deeper, or just get a high level view of here's what's going on right now, right? And I think that this isn't a replacement for anything else, but rather an augmentation of the automated or real-time status indicators, right? Because this gives you an idea of, oh, there's a maintenance going on, right? It's pretty easy. And since I have 1 minute left, I guess I'll end now. I couldn't resist. I put one thing at the very end. Now you're thinking of portals. So with that being said, and I realize we're at time here, questions, comments? I think we do have some slot built into the schedule, so I'm happy to talk about any of that.
Yeah, right now we've got about a 15-minute break slotted in before we get into the lightning talk. So you're free to ask questions for Dan. People are free to take a break before the lightning talk. But yeah.
Okay. And just a reminder that if this is something you're interested in participating with, just reach out to Corey or myself and we'll get things moving.
Dan, we do have a question in chat from Dave Morrow of what GeoIP database are you using?
Well, that's a good question. I think we're using MaxMind.
I think it's the GeoIP that's built into Elasticsearch.
Yeah, it's the MaxMind free.
Yeah, and as with all good GeoIP, it's mostly accurate. It's usually good enough for the type of accuracy you're looking for a visualization like that. Other questions? Okay, well, it sounds like we've got a lot of follow-up on some of the auth components. I think we can follow up with some of those offline. And if there's nothing else, then I will just simply say thank you for your time. It was my pleasure to be able to go in and talk about some of this. I'm very excited about these things. I think that we've been able to make some great strides in reducing some of that complexity and growth. And I look forward to working with more of you in the future on it. So, thank you very much.